In late November 2025, the island of Sumatra in Indonesia faced one of its most deadliest hydrometeorological disasters to date. A catastrophic flood event that not only devastated communities, but also shocked the entire world with its sheer scale and intensity. But here's the surprising twist. This massive rainfall was far from unexpected, as Indonesia's Meteorology, Climatology, and Geophysics Agency, known as BMKG, had issued clear warnings about it fully 8 to 14 days in advance, giving ample time for preparation. So, this raises the burning question. With such accurate predictions in place, why on earth did this forecasted rain escalate into a full-blown mega-disaster of unprecedented proportions? To uncover the truth, let's methodically dissect this event using hard scientific data, precise measurements, and absolutely zero hype, revealing the true anatomy of this shocking catastrophe step by step.
Behind every question lies discovery. I'm Saluna, and this is SciCurious, where we uncover the science shaping our world.
At the heart of Sumatra's frequent and intense weather dramas lies the island's highly unique and dramatic geography, which sets the stage for extreme events like this one. Dominating the landscape is the majestic Bukit Barisan mountain range, stretching like a formidable natural barrier along the entire length of the island, influencing every drop of rain that falls. This rugged terrain creates numerous steep river basins that function like giant natural funnels, channeling massive volumes of water downward at rapid speeds toward populated lowlands. Although Sumatra has a long history of destructive floods over the decades, the 2025 event stood out as truly unprecedented, surpassing all previous ones in both its immense scale and the level of devastation it wrought. Now, turning to the core science behind it all, the sequence began with a tropical cyclone seed intriguingly named Senyor, which formed far out at sea and set everything in motion. This initial seed rapidly evolved into a massive moisture conveyor belt system, relentlessly drawing in and transporting enormous quantities of water vapor directly from the vast expanse of the Indian Ocean Strait towards Sumatra's shores. Upon colliding with the towering Bukit Barisan Mountains, this supercharged, moisture-laden air mass was forcibly pushed upwards through a meteorological process known as orographic lifting, where terrain forces air to rise rapidly. The result was explosive and highly localized rainfall rates, dumping torrents of water precisely over those vulnerable steep river basins, overwhelming them in a matter of hours. Remarkably, BMKG's sophisticated weather prediction models, including the renowned ECMWF and GFS systems, had accurately forecasted this exact atmospheric configuration well in advance. Then why didn't it remain just heavy rain? The devastating answer lies in a perilous synergy of multiple factors amplifying each other dangerously. With extreme rainfall volumes hitting basins that were already fully saturated from prior rains, the ground simply could not absorb any additional water, leading to immediate and widespread runoff. Compounding this was a critical lag in the disaster response efforts, creating the ideal conditions for what turned a bad situation into a true mega-disaster. In upcoming episode 2, we'll dive much deeper into that response lag issue and save the detailed analysis of basin damage for episode 5, so stay tuned for those revelations. Here's a fun fact to ponder. Indonesia's orographic rainfall phenomenon is truly world-class, representing a meteorological marvel that produces some of the planet's most intense rain events on record. Senyor's notorious train effect kept a steady procession of rain clouds parked over the exact same vulnerable spots for hours on end, drenching them relentlessly without mercy. This 2025 catastrophe strikingly echoed major past floods in Sumatra from 2006 and 2013, but it proved far more severe due to the cumulative wear and tear damage accumulated in the river basins over the years. Indeed, the extreme rainfall of 2025 was unmistakably telegraphed by clear atmospheric signals that scientists received loud and clear through their monitoring systems. Next time on this series, we'll tackle the intriguing question: did long-term damage to the river basins make this mega-disaster completely inevitable, no matter the warnings? If you're enjoying this scientific deep dive, Be sure to like and subscribe right now for episode 2 so you don't miss out on continuing our fascinating journey, and above all, remember to stay dry out there wherever you are.
There's always more to discover. I'm Selu, and this has been SciCurious. Stay curious, and I'll see you in the next wonder.